Subscribe and click the notification bell to stay updated with the latest videos from School of Technology, Management and Engineering NMIMS in
Good morning, one and all. This is Gaurav Paliwan, FDP co-coordinator and faculty member of NMIMS. It gives me immense pleasure to extend a very warm welcome to our Honorable Vice Chancellor, Dr. Ramesh Bhatt, Director, Dr. Prachi Gharpure, Dean MPM STME, Dr. Alka Manji, FDP Coordinator and Associate Dean, Dr. Akhil Bandawala, dignitaries and educators present. For the inaugural ceremony of AICT-funded 5 days Atal FDP or Internet of Things, Concepts and Implementation, organized by School of Technology, Management and Engineering, NMIMS in campus. Today, we have all gathered here to not only deploy plethora of knowledge in the field of IoT, but to also create a learning environment where confidence for the accreditation will boost individuals' development. It is our culture to remember Goddess Ma Saraswati before everything we start. So let us begin the proceedings of this inaugural ceremony with Saraswati Vandana and virtual lens lighting to seek the blessings of knowledge from Goddess Saraswati.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणां वरदण्डमण्डितकरा या श्वेत पद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवैः सदा पूजिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा
Now, I request all the delegates to pay their kind attention for NMIMS and
इन्दु तुषारहार धवला
We do what's right and not what's easy. We give our best shot each and every time.
We set the standard, we are the future. We are a part of this institute so fine. NMIMS,
Respect the past, create the future, transcend horizons, however far.
we have what it takes, we make a great team. At NMIMS, each one is a star.
वर
I, Dr. Nidhi Asthana, FDP co-coordinator and faculty member of STME NMIMS Indore, am extremely privileged to introduce the guest of honor, Dr. Prachi Gharpure, Director NMIMS Indore Camp, who has been very instrumental with her extensive knowledge in the field of computer engineering. Dr. Prachi Bharti has completed her master's in computer engineering from VJTI and PhD in technology from SNDT. She has over 3 decades of experience in teaching and academic administration. She was associated with SPIT Mumbai as principal ma'am. Ma'am has started her career as lecturer with Sardar Patel College of Engineering, Mumbai, and later she joined Sardar Patel Institute of Technology in 2006 as professor and HOD. During her career path at SPIT, she has grown to take up the leadership position of heading the institution as principal. Her area of interest are computer programming, computer organization, object-oriented analysis and design, project management, electronic communication, digital electronics, and software engineering. Her areas of research are e-learning and software engineering. She has numerous national and international publications and research. Man has also won awards to her credit. Recent one being Higher Education Forum Award for contribution to information technology. He has convener of several Mumbai University committees related to affiliation, approvals, and fact findings. Now, I would like to call our beloved Director Ma'am for welcome note.
Ma'am, you are muted.
A very warm good morning to one and all. I am honored to welcome our Honorable Vice Chancellor, Sir Dr. Ramesh Bhatt, who is a strong convener of bringing academic excellence in general and particularly at NMIMS University, and is always a role model for us towards this initiative. I thank him for accepting our invitation to preside over today's function. I also extend a warm welcome to today's chief speaker, Mr. Thierry Oscar, an associate and affiliated researcher at University of Bonn, Germany. I extend my welcome to all the expert speakers who will be enlightening us with their knowledge and wisdom over the period of 5 days. Experts from IIT Guwahati, from IIT Indore, NIT Warangal, IIT DAVV Indore, IIIT Nagpur, scientists from BARC, MITU Skillologies, Pune, Cognifront from Nashik, NMIMS Mumbai, and last but not the least, NMIMS Indore. I welcome all the experts and thank them with all my heart that they have agreed to give their expertise towards this FDP. Most importantly, I extend my hearty welcome to all the participants who have joined us today. It's a beautiful morning in Indore, and I so very wish that we all could have welcomed you physically at our beautiful NMIMS Indore campus. With the legacy of 40 years, NMIMS has grown from being one of the top 10 B schools in India to a multidisciplinary deemed to be university with 8 campuses, namely at Mumbai, Shirpur, Bangalore, Hyderabad, Indore, Dhule, Navi Mumbai, and now at Chandigarh as well. And 17 constituent schools that include management, engineering, pharmacy, architecture, commerce, business, performing arts, economics, science, law, aviation, liberal arts, architecture, branding and advertisement, hospitality, and also distant learning. NMIMS has been awarded Category 1 university status by MHRD, Government of India, and re-accredited by NAAC as A+ grade. NMIMS Indore campus started its operation with an MBA and MBA Tech in computer engineering program in 2017. The next in line that were added were School of Commerce, undergraduate program in engineering, and School of Law, respectively. With the state-of-the-art infrastructure and laboratories at Indore campus, we offer the best-in-class facility in this region of the country. I must thank AICT's Atal FD program initiative. It's certainly praiseworthy initiative that gives pan-India faculty members to upgrade themselves from expert all over the world. And I hope all participants will take full advantage of learning from the masters in the area of Internet of Things. I wish all the best to each one and hope session will not only be interactive, enjoyable, but also contribute to your learning. I end with Gandhiji's quote, live as if you were to die tomorrow and learn as if you were to live forever. I welcome once again all the participants. Thank you. Thank you very much.
Thank you so much, ma'am, for your valuable guidance. Your presence and kind words always inspire us. Now, I would like to introduce our chief guest, Honorable Vice Chancellor, Dr. Ramesh Bhatt, a dynamic individual and a proficient speaker. We are grateful to him for accepting our invitation and becoming the chief guest of today's inaugural ceremony. Dr. Bhatt took over as the Vice Chancellor of NMIMS University in December 20. He brings NMIMS extensive expertise and 4 decades of teaching, research, consulting, and administrative experience. Before joining NMIMS, Dr. Bhatt served as a professor at IIM Ahmedabad and as the executive chairman of a co-founded company, Bond Management. Dr. Bhatt has served as a visiting faculty at University of North Carolina, IIM Udaipur, ISB Hyderabad, and worked at the Institute of Chartered Accountants of India and Sri Ram College of. He has worked on multiple long-term consulting assignments with the ABT Associates India, DFID, New Delhi, Royal Netherlands Embassy, India, and various short-term consulting projects with USAID, CDC India, ADB, European Commission, and the WHO. In addition to his academic responsibilities, Dr. Bhatt is currently a board member of Basic Health, a non-profit organization. He has served as an independent director at Corporation Bank, ITI Limited, National Small Industries Corporation, Ahmedabad Stock Exchange, and various other companies. Dr. Bhatt has interacted with various corporate clients in several industries, including health, education, logistics, telecom, manufacturing, insurance, and automobiles. Dr. Bhatt holds a PhD and postgraduate degree in commerce from University of Delhi. He was a Takami Fellow of International Health at Harvard University, a fellowship awarded by International Health Policy Program of the World Bank. Dr. Bhatt's research has focused on corporate and health finance, published in top national and international journals with nearly 2,000 citations. 4th edition of his book, A Casebook in Financial Management, is recently published by McGraw-Hill. Now, I would like to call Honorable Vice Chancellor Sir to enlighten us with his words of wisdom.
Well, thank you very much for this introduction, and I must first congratulate the Indore campus and the leadership, Dr. Prachi, Dr. Bandukwala, Dr. Nidhi Asthana, and including you, Dr. Gaurav, so for putting this faculty development program together. And we always remain grateful to the AICTE for supporting us in this academic venture. Well, and I also welcome the participants from the various universities and the institutions who are gathered virtually today in this faculty development program. I'm sure the deliberations on the very important topic, which is, I think, going to be the game changer in times to come. In fact, it's already making a lot of impact in the industries, in our day-to-day life, Internet of Things and artificial intelligence. And I think these are going to be something very important for all of us. And it is, I think, very timely that we have come together and will deliberate on the topic as well as the various underpinnings. And also, I'm sure that the faculty development program will also reflect on that. When we have to deliver in the classroom, what is the best approach and what is the best way to teach these topics to the students and make the students future ready for the kind of jobs they are going to get. Well, at the NIMS University, we have focused on the 4 important building blocks, which are going to focus on. One is the knowledge creation, making it sure that this knowledge creation is relevant and applied and helps the society to know the unknowns, demonstrate the leadership, and meeting the expectations in the area of the knowledge creation. That is our first objective. Second is the enhancing teaching and learning through the outcome-based education system or assurance of learning system, and making our institution known and recognized for its academic excellence and the most preferred institution of learning. And also, last building block for us is the aligning the stakeholders and meeting their aspirations. And I'm sure that today's faculty development program, which you have put together, is going to help us in all these 4 building blocks, and I think is going to also help the other faculty members from the other institutions to really enhance the skills and the competencies in this area. Now, as we know that we are constantly, I think, facing a bit of volatile world and experiencing the immense amount of changes which are taking place around us. And the pandemic, particularly during the last 2 years, have significantly accelerated these changes. And the way I think the things are shaping up, as we discuss, I don't think that we are going to go back to the old normal ever. Actually, it is going to be the very new normal and something called next normal, actually. So we have to really figure out that what is this next normal going to be, and how we are going to experience this new, entirely new world, actually, which is, I think, very different, going to be very different in many respects. And the technology is going to be one central theme, that how it is going to change our way of working, how it is shaping our behaviors, how it is going to help us to prepare ourselves for the kind of changes which are taking place. And I'm reminded a quote from the Albert Einstein when he mentioned that one cannot use an old map to explore a new world. If we are going to get into the next normal, which is going to be the new world, I think we cannot refer old maps or old ways of thinking or old ways of doing the things to explore this new world. I think it is very important for us, and particularly in this next normal which we are going to face, we will need new maps, we will need new perspectives, we will need new thinking. We will need maybe innovating many things which we have been doing, and something in a very different way. But one thing is sure, that we are not we will not be able to move forward with the old thinking, old perspectives, and the way we're doing. So I had an opportunity to in the last few weeks at several forums discussing this next normal, and I think very aptly the today's faculty development program which you have put together, I think it is going to reflect many issues related to that next normal. I think when we talk about the next normal, and particularly from the perspective of NMMS University and as an academic institute, the most important theme which will get discussed is the what is going to be the future of work, and what is going to be the talent ecosystem which the industry will need in future. What kind of skills, what kind of competencies, what kind of knowledge, what kind of attitudes the industry will require in order to excel in the emerging scenarios. Second theme which takes a prominent place in discussions is if we have to prepare ourselves, if we have to prepare our students for the future of work and the emerging talent ecosystem, what are the shifts which will be required in our learning ecosystem? I think we need to really reflect on learning ecosystem, the way we have put entire learning ecosystem together, whether it is going to really meet the requirements of the future of work. Actually, that's the kind of skills which will be required and the kind of talent which the industry will need in future. Are we really making ourselves ready for the future, making our students ready for handling the future, and what kind of shifts will be required, or what kind of re-engineering will be required in our learning ecosystem currently today? I'm sure that I think all of us as faculty members in different institutions are really focusing on this and looking at the ways in which we must change, we must build up a new perspective and new way of things. One thing I think struck me during the last few weeks participating in the various discussions and various conferences and also our internal meetings, the fact that I think earlier we used to focus on the knowledge, creating the knowledge, imparting the knowledge as the key objective. I think is recently the first time I am hearing the frequent use of the word called skill graphs, and the kind of skills which will be required by the industry in future. There is a lot of significance and a lot of emphasis on the skills required for the future, and not just the leadership across the institutions in India, but the industry also is very heavily focusing on the skills part of the kind of an requirement from the academic institutions, and they are just looking at us as in the industry is looking at us that whether we are responding to create these new skills kind of a thing. And what are these new skills which are required? These are the skills which are needed in the cognitive area, These are the skills which are needed in the technology area. I think today's FDP is going to focus on this. And these are the skills which are needed in the social area. So the cognitive, behavioral, technical, and social skills. And industry has some kind of a map around these skills and what they call the skill graph. It is not just the technical skills they would expect the universities to develop, but they will ensure that in future, because the kind of an complexity of the workplace and workforce and work plans, I think these are the three components of the future of work, the way it is going to change. Our work plans are going to change. Our workforce kind of skills and competencies, it will be required, its requirements are different. And workplace environment is going to change significantly. So industry has a lot of expectations from the academic institutions, ensuring that the academic institutions respond to the work plans, workforce, and workplace changes, and develop the skills and competencies of the students in areas of cognitive, behavioral, technical, and social. And that is what the next normal means, that next normal is going to be really very complex, a lot of evidence coming that it is going to be the workforce and the workplace is going to be more kind of an contingent work plans. There is not going to be requirement for the students for the lifelong employment kind of a thing, because the skills are constantly changing. And the industries would like to see that the students which we train, they are in situation and they have the good skills that they learn, unlearn, and relearn this stuff very fast, because that is how it is going to involve. To us, foreign academic institutions, I think the implications of this next normal and the emerging trends in the future of work scenario, perhaps we need to look at the following. And I'm, because you will be deliberating over almost for a week on the theme, what you have chosen. But I think start also looking at examining that because of this next normal and the future of work, what are the kind of program vision we need to have? Will the program vision which we have in the past, will it remain same, or we really need to focus on the new program vision statement? I think all academic institutions must really focus on that. Given these changes, are our program vision statements require any change, modification, refocusing, realignment, redesign? I think it will be time worth spending on examining some of these important issues. While you are doing that program visioning, we also try to figure out that the way we are imparting the education, does it require any changes in the way we deliver the things and the way we are ensuring the outcomes? What are the new modified or redesigned operating models actually of our delivery system? Do we need any new career strategies for the students to develop them and to really focus on their skills and competencies for the new future of work? And how do we prepare the students for the future careers? I think some of these are very important issues. I'm sure that you will deliberate on these things. In my view, I think we have been deliberating on this. One of the things which I think will emerge as the most critical focus of our programs and program learning goals is that I think we need to build up the multidisciplinary focus among our students to really handle the future. We need the competency of the students, which will allow them to get into the multiple roles, which will allow them to get into the highly unstructured situations to solve those business problems. We need the ability among the students to integrate using their cognitive, behavioral, and social skills. You cannot just simply depend on the technical skills, but you need a very integrative approach and integrative perspective. No doubt you will need a global perspective, how the world is changing. And also at the same time, I think we need our students to become very ESG focused, and we must ensure that they have they develop the ability to decode the ESG challenges in future. So I think these are some guiding factors which will help us to shape our course outlines and create the course learning objectives, program learning objectives, as well as the course learning objectives. And I'm sure that if we devote some time on examining these things, it is going to really help us. The last thing which I would like to emphasize is that the way the hiring models in the industry are evolving and changing very fast. We have been used to a full-time job kind of a thing, situation for lifetime. I think it's fast changing with the contingent requirements at the industry level. Gig economy is emerging very fast. And the hiring models are changing from the current traditional system of hiring to project-based employment, multi-role careers, gig and contingent work situations, freelancing. I think these are the very emerging roles. And of course, besides that, I think we have been also talking with the entrepreneurship. But these are something where it's not something where the students go for the lifelong kind of an employment, and but these are very much skill-based and require a very different skills to handle them in future. Now, if these different hiring models are emerging, in fact, there's an ASSOCHAM study which says that by, I think, in next, I think, few years, the gig sector will become 50 to 70% in the service sector. So if that is the situation, how are we preparing ourselves to prepare our students? Freelance platforms where people seek the jobs on a freelance basis, it has increased from 80 to 330 in the last few years, which means that there's a lot of, I think, freelance requirements, and people are looking for those freelance jobs. Now, all this will lead to having a rethink on our academic portfolio in terms of the quality, in terms of the skill focus, in terms of our ability to co-create with the industry and focused on what kind of skills the industry will need. It also will relook at the reshaping of our campus work and how do we deliver the academic programs, and can we innovate our workflows and the academic delivery flows, ensuring robust delivery, which is hugely supported by the technological infrastructure, and where we use the very sophisticated data and analytical tools. We also need to focus on reinforcing students' experience for lifetime learning. And I think very high time to start looking at that. How do we build up the permanent virtual communities among the students? It is not just the interaction remains limited to the 2-year program or 4-year program, but I think build up something permanent virtual communities for future where through those communities, they keep on learning, lifelong learning. I think technology is going to help us quite significantly in this area, and it will also help us to design the new ways of collaborations in times to come. And also making the student lifelong learner. I think I spoke about that learning, unlearning, and relearning. I think that has to remain focused. And these we need to develop as part of our curriculum, as part of our approach to prepare ourselves and prepare the students for the next normal. Well, I wish you all the best and all the success for this workshop. I'm sure that besides the technical aspects of the technical matter, about which I know very little, you will deliberate on the getting into the technical details of the subject matter. But along with that, because we have a long week for the FDP program, maybe devote a couple of hours on reflecting on the future of work. What is next normal? How do we need to change ourselves? How our delivery models need to change? And how do we really prepare our students for the future? With these words, I wish you all the best and look forward receiving some minutes of the meeting and deliberations so that I can also learn from your deliberations. Thank you very much.
Thank you so much, sir. Sir, we are really glad and delighted to have your presence too. We will definitely try to prepare our students to be ready in new normal and learning ecosystem and build up a new perspective for emerging trends. Sir, I hope your depth knowledge and experience will add an important dimension and make a valuable contribution to one and all. Next, I would like to call upon Dr. Akhil Bandrawala, our highly energetic associate and coordinator of this event, to apprise all of us about the Atal Faculty Development Program on Internet of Things. Over to you, sir.
Thank you, Dr. Nidhi. Honorable Vice Chancellor, SVKM's NMIMS deemed to be University, Dr. Ramesh Bhatt, sir. Respected Dean, MPSTME, Dr. Alka Mahajan, absentia. Our campus director, NMIMS Indore campus, Dr. Prachi Gharpure, madam. All the distinguished experts of various sessions from industry and premier academic institutions. Atal peer review expert, Mr. Sanjay MG, Encore Management Services Private Limited and coordinator of Akshay Urja Abhiyan. All my dear participants and my co-coordinators, Dr. Nidhi Asthana and Professor Gaurav Paliwal, without whose support this activity couldn't have taken shape. I thank you all for your time and patience. I especially like to thank our Honorable Vice Chancellor for his kind words, and we have tried to note down all the key pointers you have given to us, sir. But I can assure you, if not all the skills of the skill graph, we'll definitely focus on two. That is, one is technology, which goes without saying, and the cognitive ability of learning and learning the technology and delivering it further to the students. So we'll make our effort to do that. So going further, we all understand that the IoT business opportunities are endless, as it covers most everyday life and market areas. It connects various tech products from banking terminals to smart home platforms. From the engineering point of view, IoT era begins at the point where there are more devices than people connected to the web. In 2008, the point was reached. And since then, we are living on the Internet of Things environment, regardless of our personal age. All this could sound dark and slightly doomed, but in fact, the non-human segment of the Internet gives us a chance for the global economy to become more human-oriented. In conjunction with other advanced technologies such as AI, machine learning, the Internet of Things is a real opportunity for us to solve problems that humanity could not cope with over the years. For example, inequality, poverty, inequitable distribution of resources, and much more. And of course, the Internet of Things can free whole class of people from doing mechanical. So with this premise, we planned and submitted our application for Atal FDP funding to organize faculty development program in the most relevant area of common interest that has enormous business opportunities. And also we thank AICTE for granting us permission and funding to organize this. So the theme of this FDP, as you all know, is IoT, concepts and implementation. This 1 week FDP will have various expert sessions and lab hands-on sessions by industry experts. So today, immediately after the inaugural ceremony, we would start with an introductory session on what is Internet of Things. It will include machine-to-machine and userless communication, components of IoT solution, competing standards for IoT, IoT specialization. So this session would be conducted by Professor Thierry Odo from Bonn University, Germany. This session will be followed by a post-lunch session on data acquisition and cloud fundamentals with IoT, wherein we'll discuss about sensors, data collection points, embedded platforms, software development, connectivity options, connecting sensors to the cloud, scaling the number of sensors. So this session will be conducted by Dr. Dinesh Singh Thakur from DIAT DRDO, Ministry of Defense. Immediately after the tea break, we would be having hands-on session on introduction of Arduino programming and IoT sensor utilization with Arduino Node MCU. This will be conducted by Dr. Chandrasekhar Yammani from NIT Warangal. Second day will start with a session on IoT communication and protocols by Dr. Raksha Upadhyay, who is an authority in the area where she covers types of wireless communication, communication protocols, major wireless, short range and long range communication devices and the properties. This will be followed by a post-lunch interesting hands-on session on Python programming for IoT by our industry expert, Mr. Tushar Kutte from MITU Iskilogis, Pune. Last session of the day will be again by Mr. Kutte on interfacing sensors and Raspberry Pi with Python. Day 3 would start with the session by Dr. Santosh Vishwakarma from IIT Indore on implementation of IoT with cloud, wherein he discussed embedded operating systems, Linux and Windows-based IoT, cloud-based data collection, and ongoing IoT operations. The post-lunch session will be by Dr. Sonali Chauhan from IIT Guwahati, and she will discuss about collecting and storage of IoT sensor data, data aggregation, big data, IoT, and various use cases for IoT data. This will be followed by a hands-on session by our industry expert, Dr. R.S. Tiwari from Cognifront, Nasik, on connecting boards and sensors to a cloud IoT platform for control and command. Day 4 will start with a session on IoT analysis by Dr. Tapan Jain from IIIT Nagpur, wherein he'll talk about extract, transform, load, in short it is called ETL, combining IoT data and static data, scripting and programming with IoT data and machine learning approaches. The post-lunch session of the same day will be by Dr. Lalit Singh on IoT analytics, wherein he'll talk about cloud applications in IoT, data management and big data analytics in IoT, and research issues and some case studies in IoT. Subsequently, we will have another hands-on session on developing applications in IoT by Dr. R.S. Tiwari, our industry associate from Cognifront. The last day, day 5, will be the session, will be the day where we'll try to bring it all together and explore the startup and funding opportunities in the area of IoT, wherein it will be myself in discussion with industry leaders, venture capitalists, and MSME leadership on what we are need to do, what are the real challenges, and what are the opportunities of budding entrepreneurs and IoT enthusiasts. So last session of the day, before the valedictory session, will be on yoga for mental health and success. So this is all about the 5 days of this will be the way we will go forward. I hope all the participants would find these sessions interesting and informative with a good mix of hands-on and theoretical concepts. I request all the participants to kindly note that 80% attendance is mandatory for successful completion of this FDP. We will be sharing feedback links during each session for all of you to complete, and same will account for your attendance of the respective sessions. Also, at the end, there will be an online quiz wherein you need to score minimum 60%, generate your certificate at Atal AICTE website. With this, I once again thank our management, all the dignitaries present here, participants, my co-coordinators, and the enthusiastic student volunteers for their untiring efforts in realizing this. Thank you all, and let's start with the sessions at 11.
Thank you so much, sir. Sir, we are delighted to know about the flow of FTP and the importance of IoT. Now, everyone is requested to turn on their video so that group photograph may be captured. Ashi and Amisha, please take the screenshots.
Yes, ma'am. Ma'am, we'll be waiting for a minute for everyone to start the video.
Sure. Are we good to go, Ashi?
Yes, ma'am. Thank you.
Okay, thank you so much. So I would also like to thank our Honorable VC, Dr. Ramesh Bhatt, sir, for giving his valuable time to sparkle our event. I also extend the gratitude to Chancellor Shri Amrishbhai Patel, Mentor Shri Akhilesh Ji Rathi, Director Ma'am Dr. Prachi Gharpure, Dean NPSTME Dr. Alka Mahajan, all university authorities, faculty, staff members, and all the participants for making this inaugural ceremony possible and successful. I am extremely privileged to have you all here today. Furthermore, I would love to thank our organizing team for their hard work in arranging this event. Our first expert session on Introduction to IoT by Dr. Thierry Ude from University of Bonn, Germany, which will be starting after 10 minutes break. You all are requested to please remain logged in. Thank you once again.
Thank you.
Thank you.
Thank you, madam. Thank you for your presence. Thank you very much.
Bye.
Very warm morning to all the dignitaries on DICE, Director Ma'am, Associate Dean STME, all the faculty and staff members, and our enthusiastic audience. I, Preet Sadhwani, take immense pleasure in extending a very warm greeting on behalf of NMIMS, School of Technology, Management and Engineering family, Indore. Allow me to welcome you all to the AICTE Training and Learning Faculty Development Program on the Internet of Things, concept, and implementation. Until recently, access to the internet was limited via devices like the desktop, tablet, or smartphone. But now, with the Internet of Things or IoT, practically all appliances can be connected to the internet and monitored remotely. IoT is shaping the way we live our lives. It helps us get a better insight into the working of things around us. So, what exactly is the Internet of Things? IoT is a system of interrelated devices connected to the internet to transfer and receive data from one to the other. Before getting into the session, I would like to inform you all that a feedback form will be floated in the chat box. So please fill the necessary details correctly, as attendance will be provided on the basis of the submission of feedback forms only. It's an honor for me to introduce you all to Dr. Thierry Oscar Idor. He's an associate and affiliated researcher at the University of Bonn, Germany, visiting associate lecturer at the Institute of Mathematics and Physics. He's a guest lecturer at many African, Asian, and East European universities. He received his diploma in computer sciences from the Technical University of Munich in Germany and also holds a PhD. Dr. Ido is the lead of the IT architecture team at the Consors Finance. He was also the consultant at BMW and the technical lead and head of development at Impulse Systems. He worked at the beginning of his career as a software developer, software architect, software tester, where he gained significant experience in software development and has led various IT projects. We feel privileged to have you today with us, sir. I now request Sir to share his valuable inputs to the audience. Sir is
Good
facing
morning.
network issues and will be available in 5 minutes. Am I audible, sir?
Good morning. Can you hear me? Hello.
No, sir, you're not audible.
Hello.
Yes, sir, we can hear you.
Okay. Good morning, everyone.
Morning.
Should I share my screen or you share the presentation?
So you can share.
Hello. Hello, hello.
Yes, sir.
Can you see my screen?
No, sir. Sir, can we share your PPT?
Yeah, I'm trying to share it, but something is going wrong here. Can you share it?
Yes, sir.
Good morning, everyone. Hello, can you hear me?
Yes, we can hear you, sir. Good morning.
Okay, good morning. So my name is Thierry Edo. I will have the pleasure today to introduce the Internet of Things to you. I'll be, can you please? Hello, please go to the next slide, please. So I'll try to introduce the topic to you following this agenda. The first point is to have an overview on what Internet of Things is, which common architectures behind this, and which communication standards and model are being using to realize IoT solution. So the next point is what is the data, IoT and data, how data are being processing, managing in IT solution or IT network, IoT network. So which application interface are being also used? And at the end, I will present you two, let's say, use cases of IoT solution. The next, please. So, what is IT, Internet of the Things? Internet of Things is a network, and things are physical things putting together in a network, and those things have the capacity or are capable to be networking capability. They are get together to realize a solution. So there are a lot of definitions of IoT, and the Internet of Things is when you put things together. You have a connectivity, a network from digital and physical world. You can use IoT to collect information automatically and to share information between things using a lot of communication model. Behind the same, we have technology like IP, cloud technology, sensor technology. You have the communication standard on which any communication within IoT network is based. So the communication, when we are talking about communication, which kind of communication we have in IoT? Here I can present to you today, let's say 4 to 5 communication model. We have the so-called machine-to-machine communication, device-to-device communication. We have device-to-cloud, device-to-gateway, and backend data sharing. So each of them are using a special protocol to communicate, to share data, to share information with the other stakeholder in the network. So before we go in detail to what a connectivity is, what communication model is, and how this is working, let's first go to what layers, which architecture is behind an IoT solution. Can you please go to the next, please? Hello. Yes. So in IoT, like any kind of network, we have some layers. Here you can see that we have in internet layers, we have 3 big layers. In those 3 big layers, IoT system embedded 7 different layers. We have at the first layer, the physical layer. At this layer, we have the so-called edge computing, where we have things. What is things here? For example, we have sensor, we have any things you can use to collect data are embedded or located at this, let's say, layer. So in here, we can see 2 examples of things. We have some sensor, we have, let's say, Raspberry for providing or conducting or making so-called edge computing. So at this layer, you can collect data, but only collect data and send it to the network, to the other, let's say, members of this of the network. So we have at the second layer, the network layer, we have the cloud. For example, we have the data ingestion and data analysis. At this layer, you have elements or things which can give you the opportunity to put together things together, like a cloud. I talk about device to cloud, for example. Truth cloud, you can put two devices at least together and communicate over the cloud. You have data ingestion layer and the data analysis. There are two layers where you can store, process some data you collect from the edge. The edge is the first entry of the network, the IoT network. So at the end, we have the so-called application layer. At the application layer, you have the interface. You have the application and its interface a user can use to interact with an IoT system. So we can move to the next slide. Here we have some standard and protocol. As I showed in previous slide, we have three big layers corresponding to internet layers, and we embedded in the three layers the so-called IoT layers. So each layers, here we can see that at each level we have specialized protocols and standards to be used for different action. So we have, for example, at the first layer, you have some protocol, for example, IEEE 802.15.4 meg. With those protocol, you can link the network. And then we have the internet layer, where you have protocol like CIS-LoWPAN. You have protocol like IP routing or IPv6. I will have the transport layer. At the transport layer, you have two, UDP, DTLS. You can see here at what we have here as UDP is a protocol on which, for example, the protocol constraint application protocol is based on, which is located at application layer. At the application layer, we have the most important, let's say, IoT protocols used for different things. The two important are MQTT and CoAP. So data collected from the edge are transferred in some, let's say, data format, which are, for example, binaries, JSON, CBOR. And at the last application layer, you have IoT application and data management layer. You have no protocol. The protocol you have at application layer, transport, and internet layer are those you can use to deal with data from, let's say, sensor to actual or over the cloud, put it into database and whatever. So there, the main protocol here, people ask why we don't have HTTP. HTTP is a protocol used mostly in internet solution, but is resource consuming. Instead of HTTP, most IoT solutions are using CoAP, but can also use HTTP, but it's not so common in IoT solution. I will show you later in which communication model you can also use which protocol. So please to the next. So as I said from the beginning, we have some communication model. The first one, or one of them, is the machine-to-machine communication. What is machine-to-machine communication? Commonly called M2M. This communication model help in a solution, in IoT solution, to communicate automatically without any manual or human interaction between many systems, many machines or devices. And the point here, why we are talking about, or we are saying machine to machine, and how this works. Machine to machine, at least you have two devices which want to communicate, exchange data, collect, send it, or whatever. How this works? Between both, we have a server. I send my data to the server, and that the server knows which receiver will use this data, or the receiver requests himself from the server this information. Example for this, you have, let's say, a thermometer collecting in a room which degree we have. This can send the information to a remote server, and this remote server can decide to send, based on this collected information, to send a command to another, let's say, device, maybe in the same house or somewhere else, to perform an action. So here you can see how what is the topology of this communication. Next, please. So here I have some example from the internet. I can show you how this works. M2M solution here, you have in the central a server. You see here we have a camera. We have here cars or trucks transporting some goods. You have also a telemetry, energy smart metering and whatever. So let's say you have to move from point A to B with your truck. You have food, you transport food. So, and we are in winter. Here at the road to that place, you can receive information, and this will change automatically the routing in your car without you know why. Maybe he will tell you, please, the road is closed, or this road cannot be, or we have traffic jam on this road. So automatically your device in your car will tell you what to do, because he received information from outside, let's say from the internet or from weather station, and guide you. You can see here we have a lot of devices working together. All those devices are networking capable. That means they can collect data, they can get together in a network. That is very, very important. You cannot put in IoT a device which is not network capable or cannot networking. So all those are putting together to provide a solution. That is here, and everything is without human interaction here, because nobody is handle a device to perform an action, to collect or to do something. All what is happening here is fully automatic without human interaction. So we have the next communication model called, please, the next, called device to device. The first question coming up here is, what is the difference between machine to machine and device to device? Because device is also a machine, but why both communication model are separated? So device to device, people call it device to device because we are talking here of two machines connected together without any intermediary, no server between them, and the communication distance between both is very, very tight. And for this communication, you have a special protocol to use, like also for machine to machine, we have special communication protocol. I'll be back to this later. For the communication here, for example, when we have two smartphones and we are exchanging music between both, you, your friend, you are changing or exchanging some musics between and using, for example, low Bluetooth. So you cannot go far than 10 meters between both devices to perform this communication. Here you have nobody in the middle to serve as server to help this communication. That's why that is the difference between machine to machine and device to device. Machine to machine, you go through a server to put at least two counterparts, two devices together for a communication or for a solution. In device to device, no intermediary, only both devices are putting together and communicate with each other through special, let's say, protocols or standard. So here I have also an example to show you how this is. So you can see here you have two devices. Here is a light, and you have here a light switcher, and both are networking. At networking, they have the capability, the connectivity capability to get put together, and are using wireless in a wireless network, because for IoT solution, you have two type of network, wireless and wired network. And here you can see we have Bluetooth, Zigbee, and Z-Wave protocol, which are special for device-to-device communication. If you switch off or on, this will send a signal to the light, and this light can go off or on. But you have to respect some distance between both so that that can work. When we have, let's say, small cars kids are using to play, they have, yes, you have a commander. You can use it wirelessly to handle the car, to drive the car. And if you go too far from this mini car, you cannot handle it anymore because the distance is too big, and you have any more the possibility to use, because those three network communication protocol are only for short distance. So then we have the next communication model called device to cloud. Device to cloud is when a device sends data or receives data from the cloud. Who behind the cloud is using this data, or how this is handled, it's not important for the device which is sending or receiving the data to the cloud. The central point here is you have the communication between device and the cloud. So for this, we have an example to show how is the topology, the architecture behind. Hello? So you can see here we have the cloud is the service provider. And you have here, for example, two devices. He can send or receive data from the cloud based on the solution you design, the architecture, the application, or the goal of this communication. And they are using a special protocol. So this is similar to machine, but here you have cloud to cloud, a cloud which are the central point. You don't know exactly what is behind this cloud. But machine to machine, you know exactly which server is dealing with this communication, which server is serving the whole. You can see here we have HTTP for internet communication. We have TCP, on which the so-called MQTT is based, and on the next side you have UDP is also on this. You have the so-called CoAP protocol, and they have different meanings. So you can see both can work, but with a different protocol, which I show you some layers. You can see that we have TCP IP on internet layer and DTL's UDP also on internet. Yes, on the transport layer. So, and CoAP HTTP or MQTT are embedded in application layer. So here it depends which kind of layer you are using here for the communication. You choose the right protocol for your solution. Here we have an example of cloud-based communication, which is similar to machine communication model. So the next communication model is, please go to the next. You have here the so-called gateway-based communication. So to communicate with the device, you have to go through a gateway, the IoT gateway, which will allow any application to serve, to exchange, or to deal with another application or another devices. And this gateway we have in normal, we have the application gateway you can use to let external partner or internal application to communicate with the service. This device to gateway communication model are working exactly like that. You have a gateway between, and this gateway know exactly when you send a request, what or which a service will be handled with and which response you will receive. So we have also here an example of device to gateway communication model. Dennis, please. Hello, Dennis, please. So you see, we have similar topology like cloud-based communication and machine to machine. Here you have between both a gateway. Any communication you want to do has to go to go through to this gateway, and between the gateway and the application and the cloud, you have the internet, and here you can use the internet protocol to provide this communication. So what we can conclude here, for each communication, depending on who and who will communicate, you have special protocol. And each protocol is designed for doing things, special things. I will show you later the difference between MQTT and CoAP, when what has to be used and for which purpose. So that is in some communication model in an IoT solution, or let's say network. So We have also how data, please go to the next, how data get shared behind in backend level, in backend network. So you can see, please go to the next, we'll see the example. You see here, we have, for example, 3 application service providers. And we have an application, a sensor, for example, and not a TINS, a physical TINS, which can collect data. Hello? Which can collect data. No, please back to the, yes. Collect data and send to the provider 1, which will dispatch this to another communication. This is like how the data are shared behind the scene. This is only an example of how you share it. You have only one who is collecting the data or using this data, and in an orchestration model, you share the data between the application. We can have also a communication between application 2 and provider 2 and 3, or provider 2 and something else, etc., etc. So this is how they are changing and which protocol they are using and which data format we have, for example, between provider 1 and provider 2, or between provider 1 and provider 3, you have the data format JSON, and you have the authentication protocol out 2.0 and internet communication protocol HTTPS for secure communication. So between the sensor, you have QoAP or HTTP. I told you in previous slide that HTTP is not a common protocol used in IoT because too resource consuming. But sometimes when you want to communicate with the internet, that is the more appropriate protocol. So I'll back to this later, why we don't use MQTT here and you are using QoAP. That's half a minute. QoAP, you use QoAP in some constellation. If you want to deal directly with the internet, QoAP is the most appropriate protocol to use to make the connection with the things and the network, internet. So here is how data get shared behind the scene, and you as user, you have no idea about what is happening behind. You can maybe see the physical parts collecting data and send it to the internet or to other application behind. So now let's move to how data gets collected and which application, which protocol are used for those things. I select 2, let's say, protocol to show you when you have to use which protocol for the data collection, data ingestion. We have the MQTT, MQTT, which is message queuing telemetry transport. And this is implementing a model which called publish and subscribe. You subscribe to an action or to collect some data, and you publish this, and only MQTT have this possibility to do that. So MQTT is a simple messaging protocol. It's designed for constrained device with low bandwidth. MQTT allows you to send commands to control output, to read data, what we call also to collect data from the physical things, for example, sensor nodes, or for something else, and send to the network. So you have here a subscribe and publish relation, and MQTT help you to do that. The next most used protocol in IoT is CoAP, Constraint Application Protocol. This is for request and report. You can request something, as we see in the previous on the previous slide. You see the sensor, or not the sensor, the things can request from the provider or can report to the provider one. And MQTT, not MQTT, sorry, CoAP, the Constraint Application Protocol, is specialized, as I said before, in transferring data to the web. This protocol is designed for machine to machine application. And we have a lot of examples for machine to machine application. We have, for example, smart energy management system, which consists of the light knows when he need to go off or on to save energy. And this is also through a server, local server or remote server. We can have to manage a countrywide energy consumption. We can have a machine to machine communication, which is collecting how people are using and know exactly where you need energy, and can say, okay, I'll let people in this area on this city using from 9 to 10 energy, and stop to providing energy to other city because at that time they are sleeping or they are using not enough energy. So you can manage the energy consumption in the whole country, but automatically without any human interaction. Only the server is collecting human behavior behavior, and knows exactly which area, which part of the city, which industry needs at which time, which how many energy volume, and can automatically manage this. So that is also an example of machine to machine. So the next point, or the next things to know about data in IoT is how the data get processed in IoT. So IoT, you have no defined or common accepted data processing architecture available for IoT. You can design, define, implement your data processing architecture as you think this fits your IoT solution, what you are designing. And IoT is based on two communication or processing model. You have real-time and batch mode processing. So here I listed some tools, application you can use for both. Batch is sometimes you have to wait a long time to collect more information before you send it to the receiver or to the point this need to be processed and so on. And in real time, you have event-driven mode where when you receive the information automatically, you define some events. Those events react automatically and send the data in real time to the point this will get processed. Both are possible in IoT. And how data are get stored in IoT. So you can use SQL database to save data in IoT, but this will not help you too much. Why? This is dependent on which solution and which volume of data you are dealing with in your, let's say, in your solution. But mostly, IoT are designed for collecting huge data, big volume of data, the so-called today big data. And for that, sometimes we have no strata behind. And that is the big problem. If you want to use normal SQL data, entity relationship data, you need to know which strata those data have, and then you can automatically classify those data into a table. But in IoT, if we are collecting in, let's say, in a machine-to-machine network, you are collecting data from different sources, and you have to save or store all those data into somewhere, and later use machine learning to deal with this data or data mining to see what is the meaning of those data, or what you can do with this data. You have no choice. Only the choice you have to do is to use NoSQL database designed for big data, to store big data in no structured data. Big data is not only related to the volume of the data, but related mostly to the structure of the data. The data you don't know the structure before you are collecting this and we cannot put it in a entity relationship table. So I mostly know SQL database like MongoDB. There are a lot of database technology today. Mostly used is MongoDB to store data collected from in an IoT solution or network. So now let's move to the next topic. Here is, we have 3 points to cover. The first is the user interface, like in any kind of application. If you have, we have also in IoT, the application layer, and you want to interact with the application or with the whole solution, you need to use the so-called user interface, which allow you to interact with the application. You can also visualize the data you collected. And for that, there are a lot of tools to use to visualize the data. And this is also part of any network or any data architecture. If you collect data, you have to visualize this. And we have the data visualization also in as interface in an IoT network. At the end, we have the data analytic, which is a process to analyze data you collect. And at the data for the data analysis, you need today some modern, let's say, technology like machine learning, deep learning, or artificial intelligence to perform this task. That is a bit in summary about application and interface in IoT. This is also common to any kind of application today. It's not only tailored for IoT application. You can use it for any kind of application that IoT also use this. So we are at the end of this presentation. The next part is to show you some, let's say, example of use cases where you can use IoT. We have the so-called industry Internet of Things. And here you can use IoT for many things. Predictive maintenance. You can use sensor to monitor, to collect data about some tools, some machine, and based on those data, you have the analysis, you have the visualization, you can see how this machine is working and what can get spoiled and when. You can predict when you need to go for some maintenance work. And here IoT help too. You have in an industry or manufacturing, you have a lot of tools, mobile tools people are using. And you can use the so-called RFID to mark mark those tools so that you can easily track where the tool is if you are looking for this tool later, or you know who or when a tool is put in somewhere or taken from whatever. So you can also monitoring your quality. You can be at the seat and use your IoT system to do that, or you can do it remotely using machine to machine. Your manufacturer collect the data about quality, send it to the server or to the cloud, and another application somewhere else will collect this data from the internet or from the cloud and perform some quality assessment or analysis. We have IoT also used or getting used or is coming into health care sector or field. Today, we in health care sector, people are mostly talking about telemedicine, telecare, remote care, etc., etc. And for those, you need IoT, the so-called Internet of Health thing, which can help you to surveillance some disease. You put some collector somewhere, collect information about disease to see if the disease will get spread and to prevent any kind of pandemic or endemic or whatever. You can also use IoT today with 5G to have some surgery at remote. So all those things are possible. You collect data, you can give some comments or requests and reply to perform an action at the remote. So, and use internet protocols to achieve this goal. So you have also IoT use case in the agriculture. In the agriculture, you can use IoT to check when you can put water to your to your plants, or when you have to take the fruit, the hanging fruit. You can know how long you can use light for indoor farming. If you have some plant indoor and you need to use light to give them energy, so IoT can help you to manage the whole, to collect information about this, to check when they need water, when they need light, and automatically they can manage water and light, etc., etc. Also can also inform you about hanging fruits or whatever, so that you know when you have to harvest your fruit. So that are some use cases. We have a lot of use cases in IoT, but I have here only the 3 that I can present to you. So the next point, as I told you, I will present to you shortly 2 solutions. I work on this. I will share the publication later with you, or share the, let's say, DOE, and we can search for this on the internet. So we have the first, both are Internet of Health things. The first solution I designed, implemented, and published is the risk prevention of spreading emerging infectious disease using hybrids, crowd sensing paradigm, optical sensor, and smartphone. The next is smart medicine transportation and medication monitoring system in a system I called ePharmacyNet. So the first, let me show you how this solution look like. The next, hello? Next slide. Please the next, yes. So here you can see the solution behind risk prevention of spreading infectious disease. We have here something like a drone airplane which collects data automatically by flying over a city. In this, you have the so-called fiber, which can collect temperature from more than 15 kilometers. That means if somebody on the street has fever or high temperature over the normal temperature, this device can collect and give alarm or alert the whole system. You have some sensor here at the fork and edge unit, which collect this temperature, send it over MQTT broker or let's say protocol, send it to a Raspberry Pi, which is used to publish and subscribe the information to a smartphone. What happened? This smartphone has the data, and you use the co-op protocol to send the data to the web server. Analysis and everything was performed at the cloud, and automatically the cloud sent information to a monitoring center, health monitoring center, which automatically sent a drone to the area where the measurement was taken to control which individual has this high temperature. And this happened without nobody knows about this. The drone started and fly over the area, but a bit at low, high, and can collect also to verify this or to verify the data collected. So the fiber used in this, the optical sensor fiber used in this experiment has the capability to make difference between human being and objects, physical things, and can measure exactly the temperature. This temperature gets measured. The drone can also collect information about smartphone of the person or his neighbor if this smartphone share his GPS position. And then once all those information get collected, the monitoring center, the health monitoring center can inform health and authority, and this happen very in real time, and the person will get will get taken from the mass, and also all neighbor can also put in quarantine and to verify if he's getting infected or what's happening. This is a solution you can use and access it in markets in Africa, and this work and also get published in a renowned, let's say, journal. And here you can see how IoT solution can help to deal with health topics. You see, we can permanently monitor health of the population. You can control a lot of things, but you have also to keep in mind that all those things has to follow some regulatories. You need a lot of allowance to do that, permission. You cannot collect data from people without people know about that. There are a lot of let's say, barrier to remove before you provide such kind of solution. You have to deal, you cannot use, let's say, drones anywhere. If you use it in military zone, you'll get some trouble with the government. You cannot use everywhere in every country. Also drone, you need permission for that. Everything you have to do, you do here, need to be in accordance with the law. They need to be compliant. You need to take care of the so-called GDPR, data protection regulatory. You need to have permission of people, because people need to give you the consent before you collect the data. And if you collect the data, you need also the consent if how you can deal with those data. So you see, design the solution, implementing is not a big part, but the regulatory, the compliance part is also a big topic to keep in mind and to work on this too. So here in this system, we have the cloud is where you collect the data. The optical sensor fiber are the physical things you use to collect the data. The smartphone is here to make the bridge between both parts of the system, the collector, the data collector, and the web. And it's also a things you connect to the collector. You have the drone, which is also a things, having some sensor, collect data. And you have the cloud, where you have the database, you have the data processing application, you have a lot of things on the cloud. So you need here also good internet connection. And for that, you have also for IoT, you have the so-called LoRa and so on. So that is, which are protocols for data exchange in some area, because if you don't have the internet or whatever, I will not talk about LoRa today. Maybe I will send you some document to read about LoRa when you need to use LoRa or SIG for the data exchange and the connectivity and whatever. So the next example is the smart medicine transportation. As a short history behind, in some poor countries, we have the issue that if you want to buy a medicine, sometimes you need to go to many pharmacies before you can find the medicine or not. And this problem is very present in Africa. It's a common issue in Africa. So I designed, let's say 10 years ago, a solution to solve this problem. But we still have some problem. If you have somebody at a remote level, let's say you have a pharmacy which is 200 kilometers far from the residence of the patient, and you need to send to him this medicine. As we know, we need to prevent against frauds, because you can buy, somebody can buy good medicine from the pharmacy, send it to the patient at remote, and the deliverer can change this medicine on the way to the patient. To prevent this fraud, to prevent the patient from any health damage, I put in place a system to safely transport the medicine from pharmacy to the patient. As you can see on the slide, you see a box where we place the medicine, and this box can only get opened by the patient because he received from the pharmacy a code, and only he can open this. You see also we have a mobile phone, a smartphone, which is always controlling the distance, the position of the bus if nobody take the bus from the motorcycle. So you have here a communication, a D2D communication between a mobile phone and the bus. And behind, inside the bus, you have temperature sensor, which is measuring the temperature and can let the deliverer know how quickly he has to drive so that the medicine will not get spoiled before he attends the patient in place. So to avoid delay in the delivery, we need to use GDPR doesn't properly work. So we have, in this system, we have a, let's say, routine application based on the crowd. We have people which are using the mobile phone to inform the central center about the traffic jam, and that this central send this information or those information directly to the deliver routine application, which inform the deliver which route he has to take to quickly attend the patient, let's say, residence. And this is also a system helping you to avoid time delay, to save the medicine during the transportation, prevent those the patient from using fake, the so-called counterfeit products or medicine. So there are two systems of IoT solution designed, tested, and published in renowned, let's say, journals, and show how IoT can help in health care fields. So I think we are at the end, and we can have some multi-choice questions. Okay. Let's first go through, have a question and answer session. And at the end, we can have, if we have time, the multi-choice question session. So I thank you for listening to my presentation. I hope I keep this short. And now we can open the question and answer session. The floor is to you. Thank you.
Thank you, sir, for such an instructive and informative session.